sodium, potassium, rubidium, cesium, and francium.
Hydrogen, lithium,
Sodium, potassium, rubidium, cesium, francium.
Good. What about the group 2?
Yes, sir. Beryllium, magnesium, calcium, strontium, barium, radium.
Beryllium, magnesium, calcium, strontium, barium, radium. These are the elements
sir.
are there in the group 2.
Yes.
So today we'll study 2 more groups in the end of the class, okay?
Yes, sir.
but in the last class we discussed about the different things, right? About the classification of matter. One minute. So in the previous classes, we discussed about the classification of matter, completely solids, liquids, and gases. And the chemical classification also we finished. Pure substance, that is the elements and the compounds. How many elements are there in the periodic table?
Sir, 118.
118 elements are there in the periodic table. Those are metals, non-metals, and the metalloids. And what is the definition for compound? What is the definition for compound?
Sir, a compound is a pure substance which is a mixture of 2 or more elements of different kinds. It's the combination of 2 or more elements in a fixed ratio by mass.
Very good. A compound will contain 2 or more elements, but they are combined chemically and present in a definite ratio. Right? A compound contains 2 or more elements, but they are combined chemically and present in the fixed ratio. That is called as a compound. Any doubts in definition?
No doubt, sir.
Next we studied about the mixture. Mixture means what? It will also contain 2 or more elements, but they are present in any ratio and present combined physically. Mixture also contain.
Sir, it is impure.
Sorry?
Sir, it is impure.
It is an impure one, but it will contain in physical format, right? They will combine in the physical format. And it will
Yes,
have
sir.
the 2 more forms, homogeneous and the heterogeneous. Homogeneous means whatever the mixture is there, the mixture will have the uniform composition throughout the mixture. In the case of homogeneous, what is example for that?
Sir, salt solution, tap water, milk, ink, medicines, tea, coffee, etc.
Okay, but tap water we don't know, right? Exactly. If you take pure water, it's okay, homogeneous. But if you take tap water now, some of the cases tap water also will contain the mud particles or the impure particles, which will settle at the bottom of the glass.
Yes, okay.
So in that cases it can be heterogeneous also, right? So you cannot take
Yes,
the tap water as exactly homogeneous. Maybe in some cases we can take.
So only mineral water is homogeneous.
Mineral water we can take as a pure substance, right? It is not the mixture.
So it might contain something like irons.
No.
Okay, sir.
Okay. Next one is the heterogeneous, which is not uniform in their composition throughout the mixture. Example? What is example for heterogeneous?
Sir, sand and water mixture, water and petrol mixture, rice and lentils mixture.
Very good.
So this is all about the classification of matter. Any doubts in this?
No, sir.
Shall we move to next topic?
Yes, sir.
Today we are going to study the types of molecule. The first topic is types of molecule. What is the meaning of types of molecule? What is the meaning of molecule first?
The molecule is a substance.
Okay.
So molecules are made up of atoms.
Sir, a molecule is the smallest particle of an element or a compound, which can be broken into simpler substances and can exist independently.
Very good. Group of atoms. Simple definition is group of atoms will form the molecule, right? Yes or no?
Yes, sir.
Group of atoms will form the molecule. And the smallest substance of matter which can exist independently is called as a molecule. Solid substance of matter which can exist independently is called as a molecule. Simple definition is group of atoms is form the molecule. Suppose what is the atom? Atom is the smallest particle of matter, right? Atom is the smallest particle of the matter. So group of atoms is called as a molecule. Understanding? Group,
Yeah, yes, sir.
Group of atoms is called as an molecule, and the group of molecules will form the matter.
So compound.
Group
Okay,
of molecules will form the matter. It can be anything. It can be solid or liquid or the gas or the element or the compound or the mixture. Understanding?
yes, sir.
Atom cannot exist independently.
Sir, it may or may not exist independently.
No, atom will not exist independently because it is the smallest particle, right?
Yes, sir, but sometimes it can exist independently, right?
Can you tell me some examples for that?
Sir, but I don't know any examples, but I heard it.
Sorry.
Raghav, could you repeat what you said?
I don't know any examples for it, but I
Okay.
learned it.
Generally, atoms cannot exist independently because of small nature. That's what I said. The group of atoms will exist independently.
Yeah, yes,
The
sir.
smallest substance of matter which can exist independently is called as a molecule.
Okay, okay, sir.
Atom will not exist independently. Understand? So in this also you have the
Okay.
different types are there. One is a monoatomic molecule.
Yes, sir. A diatomic molecule.
Monoatomic molecule means what?
Diatomic.
The molecule will
Sir,
contain
molecule contains only single atom of the same kind.
the atoms of the same kind, right?
Yes, and
Yes.
atom of the same kind.
The mono means singular,
Single.
like only one.
Diatomic means in the given molecule you have the two atoms.
Different.
Okay. Triatomic means
Sir,
So
three
three.
atoms.
three atoms. Polyatomic means
Sir, more than three.
more than
Three.
three.
So I think more than one.
No. Polyatomic means more than three, we can say directly. Or you can
Sir,
say more than two.
Sir,
Okay, sir.
examples for polyatomic are sulfur, phosphorus.
Yeah. And one more thing, for all this we can say as atomicity generally. What is it? Word?
Atomicity.
Atomicity.
Atomicity is nothing but the
Number of atoms in a molecule
number
of
of
an element.
atoms present in a given molecule. What is the meaning of atomicity? Number of atoms present in the given.
Number of atoms present in the given molecule.
If you have only one atom, that is a monoatomic molecules. If you have the two atoms, so that is a
Diatomic.
Diatomic.
monoatomic.
Diatomic.
Diatomic. Triatomic.
Diatomic,
and
Poly.
polyatomic will be there. The triatomic, all the things will consider the polyatomic only. Okay.
Yes. Okay.
So examples for the polyatomic are PO4 -2. Okay. H2SO4. Understanding. In this case, H2SO4, how many atoms are there?
So, two
H2SO4.
atoms of hydrogen and
2 plus
4.
2 hydrogens of hydrogen, 1 atom of sulfur, 4 atoms of oxygen.
of oxygen.
So total 7 atoms will be there, right?
Yes, sir.
So this type of molecules are called as polyatomic molecules.
Okay, sir.
The remaining people also can respond in the class because there is only 10 members class, right? Only 9 members are there in the class. Good, Drago and the Harinius responding with me. But the remaining also can respond. Understanding? Joya, Sahasra, Ritvik, Pallav, Hanumam, Mohit, Ritvik, Jayashmita. Understanding or not these people?
Yes, sir.
Diatomic means which will have only 2 atoms in the given molecule, that is a diatomic. Okay, that is all about the atomicity. Generally, remember atomicity. Atomicity is nothing but the number of atoms present in the given molecule is called as an atomicity. So next we will go for the chemical symbols. So what is the chemical symbol first?
What is the meaning of chemical symbol? Hello?
Yes, sir, it's the formula.
It's a formula. Very good. So we have total 118 elements are there in the periodic table, right?
Yes, sir.
Each and every element will have the chemical symbol. Okay. So chemical symbols helps in the writing the chemical formulas for the given elements or the compounds. Generally, to write everything in the word format, it will take longer time and it is not convenient always. So there is a language for the chemistry where you can write the given elements in the format of symbols. Those are called as in chemical symbols.
Simply you can
Yes, sir.
say
And
chemical symbols represent elements in the periodic table, right?
yes, sir.
Yes, sir.
It
Like
represents
hydrogen 1. H is
elements in
the
the periodic table.
where it has net charge, mass.
Okay. So
So it has net charge, mass, and atomic number, sir. Every element.
So we can obtain the chemical symbols by the 3 methods. Chemical symbols generally represent the elements present in the periodic table. We can obtain the chemical symbols using 3 methods. What are those? First one, starting letter should be always capital letter. Starting
Capital
letter should be
Capital.
capital letter, or you can say uppercase letter.
So like silicon, S should be capital, I should be small.
Uppercase alphabetical letter. The next one, second letter can be, second letter should be
Lowercase.
small letter or lower case alphabetical letter. Okay, third one,
Whenever these two possibilities are not there, we will obtain the chemical symbols from their Latin names. That is also important. We will obtain the chemical symbols
The Latin name.
from Latin names. Okay, so these are the three different things which are used for to obtain the chemical symbols. Generally, it will represent the elements present in the periodic table. If you want to write the chemical symbol for any element in the periodic table, the starting letter should be capital letter and the second letter should be the small letter. If we are not using first two now, then we can obtain the chemical symbol from the Latin names. Okay. Examples. If we take hydrogen, what is the hydrogen symbol?
So H.
Capital H. If you take a
Yes.
helium, what is the symbol?
So capital H and small e.
Second letter should be small e. If you take a lithium,
Li.
So
So Li.
the first one is a
capital
capital
L and small
small
I.
I. Next one, beryllium.
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 BE.
What is a beryllium?
Capital V and small e.
Next boron. Capital B.
Boron, carbon, nitrogen, oxygen.
B. Okay. Understand right these parts? How to write? But
Yes, sir.
when you come to sodium, what is the symbol? It is not S and O, right?
So
Yeah.
so Na, right, sir?
The sodium symbol is Na. Why?
Sir, because natrium is its Latin name.
Natrium is the Latin name for the sodium. From this only we'll take the sodium symbol as Na. Understand?
Yes, sir.
Sodium, we can take the Latin name natrium. From the natrium, we got the symbol. There is a Na. So like this, how many elements are there in the
So
periodic
even
table?
for gold.
Okay, like this, how many elements are
So
there in the periodic
118.
table? Which is
So
we can
118.
take from the Latin names, not all the elements. In the
Okay.
periodic table, total we have 118 elements are there. Okay, but out of 118 elements, only 11 elements will have their Latin names. Only 11 elements will have their Latin names. Okay,
Yes,
so
sir.
I'll write of 11 elements. Or
Sir,
can
potassium also. Sir,
So
potassium.
iron.
Yeah,
So
copper.
silver,
how
copper.
many of you know that Latin names completely? 11 elements Latin names. Raise your
I
hand.
don't know all.
No, not completely, but few of them.
Yes,
Not
sir.
completely, but few of them. Okay.
For me too.
Jeshmita,
Yes, sir.
you know about Latin names?
Sir, they explained about the Latin names, but they did not tell how many elements will have Latin names or what those Latin names are.
Okay, Ritvik. What about the Ritvik?
Sir, they explained about Latin names, but they didn't tell about the names.
Okay, now I will make a list of the Latin names. You just copy that one, okay?
So can I tell few of them?
Yeah, we'll go one by one, then you can tell the name at that time.
Okay, sir.
First, we'll write the element here. Latin names.
Sir, sodium.
The first element. Next one, Latin name. Next symbol. First one is sodium. What is the Latin name for
So for
sodium?
sodium, natrium.
Natrium.
Natrium. What is the symbol?
So for gold
So
is
Na.
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 Sir,
Okay.
potassium. Sir, potassium.
Next one is a potassium.
So K.
Helium. Helium.
What is the Latin name?
Kalium.
Kalium. What's the name? Kalium.
Symbol K.
Symbol.
K.
Okay.
Next one.
Next, iron.
So
Iron.
gold. Gold.
The gold will take.
So aurum.
What is the name?
The aurum.
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 AU.
AU. Next one.
Next one, iron. Iron.
Iron. Ferrum.
Iron. What is the Latin
Fe-
name?
Ferrum.
Ferrum. Correct.
The ferrous.
Ferrum only. Ferrous is for the different compound.
Ferrum.
That will come under variable valency.
Yeah.
So
Next
copper.
Copper, cuprum.
Cuprum.
Copper.
So Cu.
Cuprum. Next one.
Then I don't know the others.
Antimony.
Antimony. Good. Remaining both
Stiburium.
spawn those who studied Latin names already. What is the name?
So I learned only those 5.
Okay. Stibium. Stibium will form Sp. Next.
Sir, lead.
Lead. Very good.
Sir, plumbum.
Name is Plumbum Phoebe.
Sir, mercury will also be there, but this pronunciation is hydrate iron something.
Next. Others.
Sir, mercury and silver, that's all.
Silver. Next.
Sir, this is all right.
Sir, tin and tungsten.
Very good. Tin.
Sir, tungsten and tin.
Very good. Tungsten and the tin. Now names. Only these are the 11 elements are there. Okay. Mercury name.
Sir, hydrate iron something.
Yeah. Good. Hydra. Hydrargium. Sorry. HYDRA RGY. It's not RG. R will come here. It will come as a HYDRA RGY RUM. Hydrargium. Symbol is Hg. Silver.
Sir, silver is argent.
Argentum Ag. Tin.
Sir, stannum.
Very good. Stannum. Symbol is Sm. What about tungsten?
Sir, wolfram.
Wolfram. Symbol
W.
capital W. So these are the different elements with their Latin names. Okay. These are the different elements are there in the periodic table, which we will call with their Latin names. Clear now?
Yes, sir.
Okay, just make it the list of elements in the notebook afterwards. Any doubts in this? Latin names, chemical symbol. Shall we move to next topic?
Yes, sir.
Yes, sir.
What is the meaning of allotropes?
So that one or more forms of the same
8th class
formula.
students, right? They studied about the metals and non-metals.
Yes, sir. Sir, if we take carbon, they have 2 or more forms, sir, like diamond.
Can you repeat again?
Sir, if we take diamond, no, sir, carbon, they have 2 or 3 forms. Like that materials, they are called allotropes.
Very good. Simple definition is existence of the given element in 2 or more physical forms.
existence of the given element in two or more physical forms is called as an allotrope, or a given element may occur in two or more physical forms because of different arrangement of atoms in a different forms. Write down allotrope definition.
Yeah,
So
yes.
will we learn balancing?
We'll study that also. Balancing the chemical
Okay, sir.
equation part, right? You are asking.
Yeah, sir.
We'll study that also. In the order is
Okay,
we'll go
sir.
first. Well, first we'll study about the basics of these things. Then we'll go for the higher concepts. Okay.
Okay, sir.
Got it. Now the textbook again. And నా దగ్గర కూడా మెటల్స్ నాన్ మెటల్స్ ఉన్నాయమ్మా. పైగా మనకి ఎలిమెంట్స్ కాంపౌండ్స్ మిక్చర్స్ టాపిక్స్ చెప్పారు కదా, డీప్గా ఏం వెళ్ళలేదు.
A given element may occur in the two or more physical forms due to arrangements. Sorry, different arrangement of atoms in different forms. Okay, this is about the allotropes. That means if you take one particular element, it can exist in the two or more physical forms. What is the meaning of physical forms? Physical form means what? Real existence will be there. Suppose if you take carbon. Carbon can exist in the form of graphite, in the form of diamond, in the form of fullerene, or you can say in the form of charcoal. So all these are real existence only, right? Graphite will exist really, diamond will exist really,
Yes,
fullerene
sir.
will exist really, charcoal also will exist really. So same carbon will exist in the different formats because they have different types of arrangement of atoms. Maybe in the graphite, the atoms are arranged loosely, carbon atoms. In the case of diamond, they are arranged very tightly and in the three-dimensional structure. In the case of fullerene, the carbon atoms are arranged in the spherical shape like a football. Understanding? The same element may exist in the
Yes.
different physical forms because of arrangement of atoms are different in the different physical forms. Clear?
Yes, sir.
Or anybody has doubts in this? Any doubts?
No, sir.
No, sir. So then is isotopes.
We'll discuss that also one by one, okay? All the things will come. Don't worry. I said you at already chemistry portion. What are the topics we're going to discuss?
Yes, sir.
Still we are in the essential ideas of chemistry only. Okay, now I will teach you what is the already started the periodic table. Constantly we'll go that one also. Today also I'll teach you in the next two groups. Okay, daily two to two groups we'll study that one. Okay. Next I will teach you calculation of number of protons, neutrons, electrons. Okay, today only that also. Understanding?
Yes, sir.
Isotopes, isobars will come, and balancing concept also is there. You can see the page number 7. Balancing the chemical equation. So everything will go in the order.
Sir, yes, sir. What is below diamond?
Fullerene. Fullerene.
Okay, sir.
Okay, generally it is like a football shape. All the carbon atoms are arranged in the spherical shape. Similarly, it looks like a football only.
Okay, sir.
Okay. So next one is the structure of the atom. So in generally we said like atom is the smallest particle of the matter, right?
Yes, sir, but atom is again divided into three subatomic particles,
Particles.
which are proton, electron, and neutron.
Very good. So again, first theory, that is a Dalton atomic theory. Dalton said like atom is an uncuttable particle or the indivisible particle, but that is wrong. So other theories like Rutherford theory or the Bohr's model of atom, these explain again the atom will consist of three subatomic particles. So what are the three subatomic particles of atom?
So protons, electrons,
Electrons
and
and neutrons.
neutrons.
Again, it will contain protons,
Electrons, neutrons,
electrons, and the
neutrons.
neutrons. We know that proton will contain the positive charged particle. Yes or no?
Yes, it has positive charge.
Electrons are negatively charged and neutrons are the name suggests.
Electrons are
So they don't have any charge.
neutral,
they're
negative
neutral.
charge. Neutron, no charge at all. So atom will contain three
So
particles.
neutrons have mass.
Okay. Atoms will contain three particles: protons, electrons, neutrons. Protons will carry the positive charge, electrons will carry the negative charge, neutrons will carry the no charge. Now, what is the fundamental unit of one charge? Always one charge, one unit of charge is equal to 1.60. Sorry, always one unit of the charge is equal to 1.60. You can say directly, or 1.6 you can take into 10 power minus 19 coulombs.
What is coulombs?
It's a unit actually.
This is a unit of charge. Always one charge, unit of charge will contain 1.6 into 10 power minus 19 coulombs. If it is a proton now, what will take? Plus 1.6 into 10 power minus 19 coulombs. One proton is equal to. But in the case of neutron,
So neutron that has
So because it's neutral, it has no sign.
it has
So
no.
1.6.
So proton carries plus 1.6 into 10 power minus 19 coulombs. But the electron,
So shouldn't electrons will have minus
minus
1.6 into 10 power minus 19 coulombs.
understand? The magnitude of the
Yes.
charge is same, but the proton will carry positive charge and the electron will carry the negative charge. Okay, clear up to this?
Yes, sir.
Now, if you take any atom, generally we'll take the atom in the spherical shape only. Which shape? Spherical shape. At the center part of the atom, we have the nucleus.
nucleus. It is the combination of proton and neutron.
It has an imaginary line.
Yeah. So you can see some dotted lines. Can you see that one?
Yes, sir.
They are the orbits or shells, we can call them, where electrons revolve.
So this is the nucleus, which will contain only the proton and the neutron.
Protons.
Protons and electrons. Sorry,
Protons and neutrons. Will be
Neutrons.
there.
So electrons are present on those dotted lines.
Electrons will be revolve around the nucleus in the circular path. Those are called as
So they are called orbits or shells.
orbits or shell, or we can call higher classes will study as the stationary states. Stationary state. Okay. So in this, what will be there? Electrons will be there. Okay.
Electrons.
Can you see this is the first nucleus? This is the first orbit. Can you see this is the first orbit?
Yes, sir.
And it will goes like this. It is a second orbit like this. Okay. Always whatever the orbit is there nearby the nucleus, that is the first orbit. And next one is called as the next orbit. Understanding?
Yes, sir.
Suppose if I draw here, this is the nucleus and this is the first orbit. This is the second orbit.
Next topic.
This is the third orbit. Like this, it will goes continuously.
Okay, sir.
What is this? Nucleus.
Nucleus.
Second, third. Or also you can call as in K shell. What is the name this one?
It's a K,
Yes, sir.
L, M, and N.
K shell,
K,
L shell, M shell.
M,
It will goes like this. M, N, like this
N.
it will goes. Okay. The first orbit is called as an K shell. The next orbit is called as an L shell. And the third orbit is called as an M shell. Understanding?
Yes, sir.
You can write as orbit number.
Yes, sir. Sir,
One.
and
2.
first orbit can hold only 2 electrons.
Yeah.
We can remember this by using the formula 2n square actually. And in place of n, we have to take the number of the shell. For example, it's the first shell, n value will become 1. Like that.
Yeah, very good. So first one is the orbit numbers 1, 2, 3, 4. Next one is the orbit shells, shell name. That is a KLMN. What is it? KLMN. And maximum number of electrons in each shell. It is also very important.
Excuse me, sir.
Yeah, Raghav.
Sir, I have a doubt.